All right, let's get started.
Okay, we're doing data set 1, and here number 1 is this is based on this one. Just what we discussed, this part, the for initial estimation. So here I have 3 things. One is load, one is PV, and the other is waste to energy. So for load, you have this one, load profile, and then you have demand report.
You can turn on your speaker, maybe. You can turn on yeah, so I can record what you're saying. You know.
Okay. My speaker, okay. This one you mean,
Right?
Okay.
Okay. Okay, so this is data folder 1, and here you have 3 things. So one is the load. For that you have load profile data here, and that report is here, demand report. That one we will see now. We'll see the data now. So that is this one if you open. And here, so you need 2 demand profile. One is for SIT and one is for GTC. So for the SIT estimate, it is in this spreadsheet, and JTC is here. But both are same formats. Everything is same. It's just SIT data and JTC data. So how is it? The format here you have SIT and this W1, W3. Those are all different buildings. And all the W means west. Then there is some buildings named E1, E2 means east. So depending on that, you will have either plot 1 for west, plot 2 means east. And in each building, you may have different types of facility. That is how we estimate the demand. So the demand is split into non-cooling and cooling. So here you have non-cooling weekday, and then you must have non-cooling weekend, because this is quite different since it's institute campus. Occupancy is very low during weekend, so data is quite different. So that's why we split weekday, weekend, this non-cooling, and then you have the cooling part separately for cooling. So that should give you like all the information you need for SIT. So from this file, aggregated, you will have here. Aggregated all the SIT data. So here, like each building had different premises, right? Here it's just totaled, summed up. So here you have, let me go a bit like this. So you have non-cooling part here, plot 1, plot 2, cooling part here, plot 1, plot 2. Let's go more in detail. So yeah, for plot 1, you have like 5 buildings, plot 2, 5 buildings, and each one daily profile. This is. And for SIT, you can get the total. If you want only the total, you can get the total. And so that is what is plotted here. Yeah. And same for JTC. JTC, all the data, like with the premises, each premise, that data is in this file. Same weekday non-cooling, weekend non-cooling, then cooling weekday. The same combination. And then all that is summed up like here. So here you will get all the JTC data. And here I think we try to estimate what kind of uncertainty, if we have to model load uncertainty, because this is a fixed profile. This is a daily profile, it's a fixed profile. If we have to model uncertainty, how it will be when it is more uncertain, to model that we just
which means at time 0, This is
It is likely
low.
that it won't change much
Okay.
because occupancy
So
is.
how do you? This is assumption.
Yeah, it's an assumption.
Okay.
Assumption. So we made this assumption based on how they operate,
Based on.
how SIT operate. Because at night,
Who made this assumption?
no, we did it at EDF. We did the assumption. So CUA and myself. So
Did you get any validation from some experts from Stack?
no, this is more with we need validation from SIT and GTC to see if our assumptions match how they will operate.
Okay.
So we discuss all these data estimation, everything. We in the first stage we collected data from them, and then we come back with the estimate, and then ask them, is this similar to what you had in mind?
Oh, okay,
Yeah.
okay, okay.
So yeah, so this is like the based on what we talked, we had this. So in if you want to model uncertainty, load uncertainty, then you could like start from this.
So
You could use this.
okay, so here you have hourly data, which means in your DRO model or any optimization model, it will be hourly based instead of half hour based.
Yeah.
So because some price data
Price is
price data for the market is half an hour, so you just remove the middle.
we can also make this like half an hour, not like by some interpolation.
Okay, understand.
Okay, and okay, so now if you want to have 1 year data to run something, then that is here. This is based on like the weekday, weekend, and there is some break period, like vacation period for SIT, for JDC. So including that information, we generate 1 year data.
Including that information, we generate 1 year data.
Yeah, we
based on the software in the workstation.
No. This is completely Excel.
Excel. I mean,
The demand part is completely only Excel.
only okay. What I mean is that the data is generated by is collected by somewhere or generated by ourselves.
It's estimated. More like from we started from the drawing, then with this type of thing, we tried to identify what is the type of building, and for each type, we made an assumption of load curve. Then from the it's like really from raw data, then we build, and we get like the total profile for annual profile.
Okay, but for the 24-hour data,
Yeah,
it is that one. So this data is not the whole.
This is 1 day profile.
Based on what kind of data? Based on the previous 2 data.
Yeah, previous
two sheets.
Yeah.
Okay. So for the loads you classified into cooling loads and non-cooling loads. If you talk about the entire load consumption, that will be the summation of cooling and non-cooling.
Yeah.
Okay.
Yeah.
How much percentage of cooling load?
For 40% at least.
Oh,
Depends on different times of the day, but it's somewhat like this. Let me see if I have some graphs. No, I don't have it here. Let me see. So, yeah, so this is correct. This is the dark one is the everything but cooling.
Everything
Everything else except the cooling is the dark one. Cooling is this one. So you see, it's almost 50%.
50%.
Almost 45 to 50%. But it depends whether weekday, weekend. Okay, so this is the demand one, and if you want any other like related. I think that's about it for the demand. It's clear for you?
Yeah, clear.
Okay. The next one is, let me go to this one. And demand, you also have a report if you want to have some details. I don't think you need to share the report with them.
Yes.
Yeah.
I think based on the discussion tomorrow afternoon, we can identify what kind of data. We can select the data from this all folders.
You can ask them like what they want to do, and then you decide what to share. Then they want more, of course, you can share later also. Yeah. Okay. Then I'll go to the PV. I'll first close that because it's too big. The original demand database is much bigger because it goes like from area of each library of from that it is there, so it's a huge one. I deleted all that, that's why it's this much. Do you want to see the original? No, right? Okay.
Okay, you have TMY data. What is TMY weather data? TMY,
typical meteorological year. So for weather data, this is a standard format.
Standard format.
Yeah, for if you have to buy weather data or give someone weather data, there are different formats. I think in that we use TMY. TMY, meteorological year. They will say
meteorological
year.
Which means okay. Which
1
mean
year of all the weather parameters.
Average
But
one.
that.
Is there average one? Average.
Average?
Yearly average yearly data.
No. Every 1 hour or something. Not even 1 hour. Wait. Okay, it's every 1 hour you have data. So this is the format. So you will have this is some temperature. This is also temperature, but T2M. I forgot what it is, but that's also some temperature measurement. Two meter temperature above sea level. This is Then you have a dry bulb, wet bulb.
TM is
T2M, 2 meter above sea level. It is the temperature. GHI is humidity, I think. No, RH is humidity. I don't know what they have all the weather stuff.
it's the terminology of
for weather. So it's a standard format.
Okay, standard format.
Yeah. Okay, so this is the weather profile. I think this one no need to share with them.
Yes.
Yeah, this is for 2025. You have 1 year of data.
This is the estimated future data
from
for SIT for Singapore.
Yeah, for this location.
Okay.
Then so this one we opened just now, and we use this for PV estimation and all that.
Use TMY.
We need some weather input for PV, right?
Oh yeah.
Yeah, we use this one. And
remember previously Jonathan used a Spotlight or something. It's an open source software to estimate the PV. It's a Spotlight or No solar. It's a
SolarGIS.
huh?
SolarGIS.
SolarGIS.
GIS. Is it that? I think we also refer to some things like that for our work.
Oh yeah, SolarGIS.
SolarGIS, yeah. You can give the location and you can try to
Generate the radiation.
Yeah,
Radiation of the data in the area.
Okay, so for PV profile, I think for PV, it's very complicated, this one. But yeah, I try to show you then, but we can check the report. In the report, you will have all the tables. So you had different buildings there, right? For PV, for the load, W1, E1, like the different buildings. So it's the same here. For each building, we are trying to estimate the kilowatt peak.
Okay.
And same for SIT. What will be the total kilowatt peak? That is this table. So it's around 1.1 megawatt peak. We took different assumptions and made. So like 70% means 70% of the roof area you are able to cover with panel. In that case, you will get this measurement. We thought 70% is only like acceptable, but we did for 80%, 90% also, because it will have some gap.
Okay, this is based on our assumption.
Yeah, so we made 3 cases: 70%, 80%, 90%, and for different kilowatt peak. Finally, we took only 70%.
Okay, finally we use 70%.
Yeah, same for JTC. We did estimate every building. Total is 1.8 megawatt. Okay, so
most of the time it's like a data.
Yeah. You may not need everything. That is the part. I think you will need maybe what is in the report. Let me show you the report from Teams. I will open. So it is this report, PV estimation. Okay. Not able to open from Teams. I will open my local file, but it's the same thing. PV estimation. Okay. So here you will have how we did that method and all that, what we used. Those information is here. These are our assumptions and all. But unless you have the software, this will not be useful. This is how we wrote the Python script, the modeling and all that. Finally, our estimate is this. So for SIT, you have different buildings and their height from the ground. That is important because you will know how much sun will fall on that. You remember, like I talked about the 3D model.
3D model.
Yeah.
This is what we call the 3D model.
Yeah. So it is. So this is the shapefile.
Oh, okay.
We draw this and we map it in the
GIS system.
Yeah, GIS. So it will be based on the drawing, it will know the area. It will calculate the area.
The software will automatically.
Yeah. You take this drawing and you place it properly in the map.
in the map.
Then it will calculate all the area by itself.
Oh, okay.
Because sometimes
from
building will
time
be.
to time, right? Because the sunrise from the east, then
Oh, no. This is just the building, just the area.
just the area.
Yeah, that is done by one software to build 3D model. And then there is a Python script that does all the PV estimation.
What is the software?
Oh, this one actually I told you, right? So I don't know if it is even still there in the PC. Yeah. So feature manipulation engine. So QGIS, in that only we draw this file, that drawing that I showed you. And then we add the height information to this file, then it will generate.
Okay. So this one is the the first QGIS is used to
draw
the shape profile.
Yeah. This one.
A lot of things.
This one plus the height information, we give it to that software as input. Okay. Then, so depending on from the 3D model, you will get results like roof area, the side area, each wall area. You'll get all this information. And for us, we are just looking at rooftop PV. Sometimes they may also have this kind of PV, right? PV in the wall. Sometimes they have PV in the facade.
Okay. Really? I didn't see that before.
In the wall, sometimes they have vertical the PV.
Okay.
It's like pasted.
Where is it? Where is it? Is it in Singapore?
Yeah, I think
Yes,
some
I
buildings have.
Okay.
Yeah, here we consider only rooftop. That is called building integrated PV. It's a different type of
Building integrated PV. Okay.
Yeah,
Good name.
means it will be stuck. It can't move.
Okay.
So its generation capacity will be different.
Oh.
Means it's vertical, no? So depending on the sun, the generation capacity will be different. So we take all this information and then this is just area information. Total area is this is the total area that we got as result, but SIT after discussing with them, in that some roof area is not available for PV. They are doing something else, so it got reduced. Then the same for JTC, we made estimate of kilowatt peak. So blue is our estimate. SIT's estimate was quite high compared to ours.
Why?
We discussed with them to share these results. They took it, but we don't know how they estimated it. Whether the data was different at that time, or they overestimated, or we underestimated. So we shared it with them.
Okay. So
that was the difference.
so the analyzing methodology used by ourselves and them are different. We are doing this PV generation prediction or estimation in parallel. So that's why we come here as a comparative study.
Because this orange one is done by SIT, like the construction, the engineering thing. For us, it's more for research purposes, so we just check with them. But this was their original. It seemed a little higher for each building compared to us.
Okay.
Maybe our assumptions did not.
Maybe some of our conceptions are conservative.
Yes. Yeah. So and then even in ours, so it could be something like this that affect our thing. So 70%, 80, 90 is the percentage we assumed. This is the available area. Then PV can occupy so much space.
Can you go up a bit? I can screenshot the comparative figure of the PV. So the green is from SIT constructor. Orange is from SIT.
Orange is from SIT, blue is from.
Dark blue.
Okay, then finally, one day, if we want to simulate PV, we have the.
Okay, so this is a consolidated one. So if we want to share the data with DCAS partners, we can share this data.
Yeah.
Okay, so in Excel file, which sheet corresponding to this data, this figure?
Question. Yeah, I don't think it's that. Let me see. No, these are all the. So one day profile. So I will add a sheet. Daily PV profile. I have the data. It's to just copy. I think somewhere. Let me search and add later. Okay, so in this I will put a mark on this one. Okay. Yeah, same for JTC. This is the shape file. This is blah blah blah. Yeah, the shape file. I don't know if it is marked here. Okay. In the shape file, you have to tell what is the available area for PV. If it is a very big building, then only little areas would be available. You have to draw each and everything. Then it will make the data. Okay.
You are the person joining this.
Yeah. Initially, Siri. So yeah,
Okay.
with Siri, this one and demand this big Excel is with Siri. We worked when I started. Okay, so yeah, there's more information and annual generation if you want. That will be roughly the annual generation.
Okay.
Okay, so that's about PV. Waste to energy.
In Excel file. Excel file. What is the solid data? Which one?
You should take this one for SIT and this one for GTC. 24 hours I will add. I will add it here.
Okay.
For SIT and GTC. Let me see if I can just add it now. We only finished. It's like 3 more folders. Let me see. I think I will have it just now. Cost benefit.
We always don't have enough time to finish work. Oh, it's here. You just copy and paste.
We have a lot of data. Now I have to see where it's coming from. I think this is the hourly. Every hour, each building, you have data.
This is simulated data.
Yes. Raw data from planning. This is not needed for you. This maybe it's useful. But what is green? What is red? I think 2 different days, probably. I took 2, one cloudy day and one. Yeah, I think it's that. Maybe I will add this. Not copy. Can we copy to a different?
Please select all and copy, please.
Okay.
Select all. And this is these are data for each building.
Huge building, and
this consolidated one.
consolidated also you prefer. Was it this one? No, this.
Yes, this one. I just select the all and control paste.
It doesn't select all.
Control A.
I was just doing the same thing.
Control C.
Okay.
Change the name, rename it. Consolidated the PV homeport. P. Okay. Reading vibes.
Okay. And this is good. So here is the
Estimation.
okay. Next is weather is okay, right, for you. Next is that waste part, waste to energy. Waste to energy, actually, yeah, I was not.
There's no data. There's no Excel file data.
It's only the simulating model and the report we have.
Okay.
Maybe report we can go through, I think.
I can roughly go through.
Yeah. But it's mostly SIT. I won't know the details, but if you have some question, I can ask them. Okay. So here, do they have some table?
This width is kind of H2 loop, right? It's similar to H2 loop. The figure you just showed me.
Yeah. Because they use
from generation to electrolyzer, electrolyzer to storage to a fuel cell.
Yeah, instead of electrolyzer, here you have that waste to energy plant. So yeah, this is that waste estimate. So I think those are this one.
I think this is a very huge workload. I think collecting this data and cleaning this data is like
yes, yeah. This is
we must spend a lot of time.
it's already head is aching. Yeah, and thing is mainly like so many people involved. So you talk to different people for different. Yeah. Okay. So I'm just seeing if there's some important table that we can go through. Finally, they estimated like I think I have the final estimate numbers I have, but all the table details I think you must see there. So finally, PDD is about it can be 40,000 people working in the campuses, both the campus together. And it can generate because the idea was to use SIT and GTC waste together. So it can generate like 20 ton per day waste, and depending on all their chemical like modeling and all that, that is able to generate 500 kg hydrogen per day.
I can't remember. Okay.
And with 500 kg per day, you can roughly generate 7 megawatt hour. And depending on this estimation, they size the plant.
Okay, so for the waste to energy production, there's no Excel file.
There's no Excel file, there's only the report. I hope there is a table in the report. Yeah. It's all that chemical modeling.
There's a lot of calculations based on. Table?
Capex, yeah, it's here. I think so. Yes. So waste to energy capacity. This is the production capacity. They take 10 dry ton waste per day. What I showed you is 20 municipal waste. Wow, 20 ton per day municipal waste. Municipal waste means it is with the food waste, like dry, wet waste together. And with the wet waste, they cannot make hydrogen. So, where is the report? Oh. Yeah, so they take 50% dry waste.
50% dry waste.
Only dry waste you can generate hydrogen.
Yes, right.
So 10 with that they took hydrogen capacity. They can generate 500 kilo per day. And yeah, let me see for fuel cells, nothing.
Who was doing this report? I think it's the guy from
SIT.
SIT. So I think it's not a guy from power or electrical engineering.
Although a guy from electrical did the fuel cell part.
Okay, but I see a lot of chemical.
Yeah, this is fully the chemical people who did it, chemical department. Yeah, but there is roughly the thing. If you want, I can put this there. Do you prefer I put it?
Put it in.
Put it in the as like comment or something.
Okay.
Okay, let me copy this.
In the final outcome.
Final numbers.
Put it in the first page.
First page or near the table?
Oh yeah, near table would be great.
Okay.
Just paste it. Okay, great.
Okay. Okay. Now I have to upload it again. Otherwise, it won't be there. So number 1 is okay for you? Should we go to number 2?
It depends on you. I think maybe we can take a rest for this meeting.
Or our 6
our meeting. I'm not sure if we can send an email to them to ask them start from 500 p.m. 3 p.m. Right?
Yeah, we can start. Yeah, I'm already hungry.
Yeah.
Afternoon also, I was very hungry. I went to lunch early. From now, it's more Excel and more Python script.
Maybe you can find out some documents for the DRO model.
I have it.
You can find it for me. So
yeah, I have it. I think I put distributionally robust, all the code
and
the document. Okay, I add the document.
I want to see the modeling. I want to see the modeling because because I'm now doing a similar thing and I got some problem.
Okay.
So I want to know how you did it before. What time it is now in France?
11.
I don't know how to say it in English to pull back on.
To prepone.
Prepone. Okay.
Prepone. Postpone.
Postpone. Prepone. Okay.
You can also say it's too late for us. Do you think they will take 1 hour?
I think we can finish as soon as possible.
In France, I think.
Sorry?
We will talk a lot in France.
Then we just keep silent. If we keep silent, they will say nothing. Then we finish the meeting.
Yeah.